Okay.
So hello everyone, and thank you for joining us today for our safety webinar on improving workplace safety, collision avoidance, radios, and braking products. Options for safe crane operation extend beyond the crane and hoist system. The selection and application of crane control equipment, such as collision avoidance systems, radio remote controls, and braking systems, can significantly impact the safe performance of an overhead crane. This webinar explores how selecting the right crane controls can improve workplace safety. Presenting today will be John Walters, Senior Engineer of Sales Applications and Technical Trainer at Magnatech. My name is Gisela Clark. I'm the e-marketing specialist at Columbus McKinnon and will be your host for today's webinar. Also joining us is Megan Foss. She is the Senior Marketing Communications Specialist at Magnatech. So before we begin, there are just a few things I'd like to cover, and if you can go ahead and forward the slides.
Okay.
Perfect. I just wanted to let you know that this webinar is being recorded. Whoops, one back. This webinar is being recorded. Whoops. One more time. There we go. Perfect. It is being recorded, as I said earlier, and we will be posting it on our YouTube channel. We have been doing these safety webinars for a little over 3 years, and so there's a whole collection of them that you can see there. We will be sending you an email probably tomorrow with a link to the recording in case you wanted to view it again or share it with someone. We will be taking questions at the very end. We like to encourage you to use the Q&A pane that you'll see in the block and GoToWebinar to ask your questions. We'll be taking them at the end. And the best question asked today will turn into a blog post next week. We have a blog with over 200 articles covering all different types of technical aspects regarding our products, primarily focused on safety. They're very educational in nature. We talk about regulations. So the best question will turn into a blog post, and you will receive some cool CMCO gear as a thank you for that. All right, so moving ahead, I'd like to just cover the disclaimer quick. We just want to let you know that this training is intended for general information purposes only. If you have very specific questions regarding regulations, we encourage you to cite the regulations or seek outside legal counsel. And from there, I'd like to turn over the meeting to the next, to John with the key topics, and turn it over to John to begin.
Thank you. Well, my name's John Walters. I work for Magnatech, and we're going to discuss 3 items relating to workplace safety that you'll find on overhead cranes. The first item will be collision avoidance. Second item, radio remote controls. And third will be braking systems. So continuing on, we're going to start with improving workplace safety, collision avoidance. Collision avoidance systems are basically an array of sensors and reflectors that are going to provide information, and those are going to be incorporated with the crane control logic. And bottom line is they're set up such that they're going to prevent any unsafe, potentially unsafe operation of the crane. In this slide, I've got a couple of photographs here. On the left, you'll notice that there's a bridge crane that is moving some 20-foot long steel bars with magnets. And to the left of that, in the lower left-hand corner, there's a control room. Well, it's important that the crane operator be advised through a collision avoidance system that they're in an area where personnel might accidentally get in the way, and so there's going to be some kind of enunciation for the crane operator, as well as some kind of an audio visual for any personnel that might be in close proximity to the crane. The picture on the right shows a bridge crane with a ladle of molten metal. It's 150 tons of molten steel. And if you look off to the left, there is a gantry crane. And obviously, it's quite important that that ladle of molten metal doesn't come anywhere near that gantry as the overhead bridge crane passes in close proximity to the to where the gantry is located at the time that they're in the same area. The idea of a collision avoidance system is to assist the crane operator basically the crane operator has a lot of input to try and manage. Their main concern, obviously, is to control the load. Okay, and by controlling the load, they've got to watch for obstacles. They've got to minimize load swing and all of that. But there's also other distractions that are going to come into play, such as voice transmission over a walkie-talkie radio, or if they're running the crane from the floor, another individual might come up and perhaps just start talking to them. If you have a cab-operated crane where the crane operator is riding the crane and there's smoke or particulate matter suspended, steam, that's going to be important to overcome with a distance detection system. If the crane goes outdoors, maybe to pick a load, there could be snow in the environment like we have here. Other areas that are typically called no-fly zones, there are places where the crane operator maybe shouldn't be in, or where they're going to have to go at a very slow speed. These are all things that the distance detection collision avoidance system basically will enunciate to the crane operator. I got some examples on this slide of some traverse motion applications. On the far left side, that blue structure there, that's the bridge crane that travels along a runway. Suspended underneath it, there's two trolleys. And in this particular application, the trolleys have the propensity to run towards each other, which you don't want to have happen if they're going at high speed, because it can damage the trolley structure itself and or lose control of the load. Just to the right of that, there's a single leg gantry that, if you look closely, is passing over workstations where there could be individuals present performing an assembly task or something of that nature, as well as to the right of that, there's a swing jib motion, which basically swings or rotates around a central axis, again, in close proximity to human beings. So in the swing motion, we're going to want to look at, or the jib motion, I should say, in the jib motion, we're going to want to look at probably restricting or enunciating the fact that in its rotation, it's in an area that you want to observe slow speed, that type of thing. In the single leg gantry, there could be an area that where there's always going to be personnel, and that you may actually want to perform a stop function. The swing motion on the far right is an outdoor crane that rides, again, it's anchored to an axis, and it rides around a circular track. And in that application, it's going to be important that the crane operator is aware that they're approaching closely to the end of the runway.
Okay, John, really quick, I'd like to launch a polling question. So if everybody could please answer this would be great. If you're on an iPad, you can just put your comment in the Q&A pane, because this doesn't work on an iPad. So everyone, how is your crane operated in your facility? Pendant push button station, radio remote control, cab operated, or not applicable? Yeah, so again, how is your crane operated in your facility? Pendant push button station, radio remote control, cab operated, or not applicable? And it looks like so far, John, 40% are saying pendant push button station, about 33% radio remote control, 0% cab operated, and 23% not applicable. So I'll go ahead and close that and turn it back over to you, John.
Okay, so on this slide that I've got here, I show two pictures of overhead bridge cranes, and the slide on the left, you see that there are two bridge cranes, and if you look, there is actually there's a pendant station that's suspended from one of them, and you'll see an individual between the two. Well, this is a real good application, again, for a collision avoidance system. The situation is the crane operator is going to be focused on a load that's suspended from the hoist. Now, there isn't one on in this picture here. You can see the hoist hooks close to the bottom of the bridge cranes, but they're going to be concentrated on the load and basically focused on the floor, and they may not be aware of the position of the other bridge crane on the same runway. So we've got to enunciate that somehow, and that could be, again, through an audible alarm and or into the control logic of the crane itself. The picture on the right, if you take a look at that, there's actually three. Now, these are cab control cranes that are, again, all traveling on the same runway. And if you look down close to the bottom edge of that photograph, you'll see some individuals standing below that. Well, this is a real good application for a collision avoidance system, as the center crane has to be able to detect the outer cranes where they're located as it moves back and forth on the runway, as well as the outer cranes have to know where the center crane is. Obviously, we don't want to get these things running full speed towards each other, or else there'll be for sure a safety-related event. Now, in both of these examples, there's also the potential that these cranes may have to do a multiple pick. In other words, each bridge crane will lift a particular load, and they'll travel as a unit. And that's where the collision avoidance system, even though it's called the collision avoidance system, comes into play, because it'll also indicate if the bridges are getting too far apart, which may also indicate that we have a potential to lose control of the load. So it can work the opposite way as well. Understand that we're going to have information fed into the control logic of the crane, and based on what you want, that's what you'll get as far as prevention of or indication of specific distances. This particular slide, I have examples of a couple of basic collision avoidance systems. On the left side, we have a single bridge crane, and on there's a sensor that produces a signal, which typically is either infrared or a laser, and it's going to be projected onto the object that you want to avoid, for lack of a better term. And then when you get into a close enough proximity, there's a reflection from the object, and that is picked up by the sensor head. And in that application, then the sensor head provides certain switching logic to slow down, stop, or what have you, to enunciate that the bridge motion is getting in close proximity to what you want to avoid. On the right-hand side, we have two bridge cranes looking towards each other, and a distance detection system on each individual bridge crane. And the idea of this is one of these or both of these cranes can be operating at the same time. And in this case, again, the crane operator is going to be focused more on the load than looking up away from the load towards the cranes. And so what we want to do is make sure that there's some kind of a signal given to guarantee that we're not going to come in contact with the other crane or in too close of a proximity, depending upon the load that's being hung on the hook. And so in this situation, you need one sensor per each crane looking towards the opposite crane. Now, what do we do with this signal from the collision avoidance? Well, it depends on the control scheme, and from what I've heard, most people in this webinar use a pendant control or a radio control. In a pendant station, this will be put in series with the directional commands and speed control commands, dropping out the high speeds to a low speed, and then perhaps dropping out the actual run command and providing a stop function for the motion. Radio control, same idea. We can also then take and disable the directional command, the high speed and slow speed, as well as turn on perhaps an indicator light on the crane or an audio alarm, something of that nature, to indicate to the crane operator. In the cab control crane, that's the center lower picture there. The crane operator is looking down all the time at the load, and they may not observe another obstacle or another crane on the runway. So again, we can disable the directional command either with a slowdown and or a stop, as well as fire some kind of an audio visual alarm. This then again, like I said, is worked into a control scheme, whether it's a contactor control or a drive control or a combination of either one of these things. And again, it helps to alleviate some of the stress on the crane operator. They have enough on their hands to try and manage. This will incorporate and allow them to provide maximum safety. So in conclusion, I would basically say, in my mind, that in all types of overhead crane applications, a distance detection, collision avoidance system, whatever you want to call it, is important to eliminate damage to the load, but more importantly to personnel that are operating the crane or people that are in the general area of the crane operation. Okay, the next thing we're going to talk about here, next subject, is going to be radio remote controls.
Okay, John,
now,
I'd like to go ahead and
yes.
launch one more polling slide quick, okay? And this is just so we have an understanding of what is the role of collision avoidance systems on your crane? Are you currently using a collision avoidance system? Are you considering implementing a collision avoidance system? Or is there no collision avoidance system currently in use? So if you can answer this question, that would be great. Or is it not applicable to you? So just give it a couple minutes. Again, what is the role of collision avoidance systems on your crane? Currently using one, considering implementing one, no system currently in use, or not applicable? And it looks like a good portion of people have voted. 8% are currently using one, 44% are not currently using one. And half, it doesn't really apply for their current situation. Okay, perfect. Thank you, John.
Okay. Well, let's continue on then with radio remote controls. And when you hear that term, basically it refers to the fact that there is a device, a transmitter that uses radio frequency or RF signals to communicate with a receiver box up on the crane somewhere. And this brings a lot to the table as far as safety. The main thing is the crane operator, it can be within a specified distance away from the load versus a pendant station that's tied to the crane somehow, which limits how far away the crane operator can be. So in the case of an event where there's a loss of load control, the crane operator can hopefully be a safe distance away. The other benefit is the crane operator not being tied to the crane with a pendant station has the ability to get full visual on the load itself. So they can see if it's hung up on something or seeing if there's an obstacle that might be in close proximity to the load or other personnel that should perhaps not even be in the area where the crane is operating. Okay. And the transmitter type that's going to be used in a situation like this is going to be based on the crane functions as well as what the crane operator is looking at. They can be a very simple push button, 1-speed, 2-speed type handheld transmitter all the way up to a full-scale belly box with countless levers and toggle switches and such. Things to be taken into consideration on this would be basically the number of crane motions that you have. If it's a single 3-motion bridge trolley hoist crane versus a dual hoist, dual trolley bridge motion, that type of thing, or maybe, as I talked about previously, doing a dual pick with multiple bridge cranes. That may dictate the type of transmitter and receiver box. Another thing would be the type of frequency that they transmit the information on. It's easy to obtain or use unlicensed frequencies of 400 to 470 or 900 megahertz, but one can, depending upon the application, use a licensed FCC radio signal, as well as perhaps a control of the wattage output from the transmitter, where we may have to transmit over long distances or through or around a lot of obstacles. Another thing to look at is if the crane operator maybe is going to be wearing gloves, they have to be able to feel the push buttons or the lever switches. So that will all come into play. Now there's options that come along with the radio remote controls. One of them, I just listed them here in no particular order, is what's called active e-stop or continuous e-stop. That refers to the fact that the transmitter is continuously broadcasting a so-called e-stop OK signal to the receiver box. And if the receiver box for some reason loses that signal, it shuts down operation of the crane. Typically, this can be termed to be a faster response for stopping the crane under emergency stop situation than having just a dedicated switch, toggle switch, or push button that just performs the e-stop function. Another useful feature is what's called a timeout, where if the transmitter is not activated after a set period of time, it then shuts down and does not allow any information to be transmitted to the receiver box unless you restart the transmitter. This is useful if you have an application, for example, where the crane operator is running the crane, they place the transmitter down somewhere and advertently somebody else picks up the transmitter and all of a sudden they're running the crane. Another very useful application would be what we call a two-hand operation, also known as a dead man switch. You may be running applications where you want full control and no inadvertent accidental operation of a particular crane application, such as a magnet or a vacuum lift. So in those applications, you'll need two hands or a set of fingers or whatever to operate simultaneously to actually perform the particular function on the crane. Range limitation is another good one. In range limitation, we can set up the distance that the receiver box on the crane will allow the transmitter to be away from it, thereby eliminating the potential for the crane operator to be too far away from the load, and again, preventing an unsafe operation. Tilt detection is important. This is useful to maintain a vertical position of the transmitter and should hopefully not happen, but if the crane operator would trip and fall or whatever, that will disable the transmitter and thereby eliminate any uncommanded motion. Radio self-test, finally, is where when one powers up the radio control system, the transmitter and the receiver do a self-check of all of their functions to be sure they're fully operational. And if they're not, the radio system won't work. Again, this helps to verify that there's total control of the crane between the transmitter and the receiver box. Contact monitoring. This goes back to the days of where you had, specifically on DC cranes, contactors, and they had the potential to weld shut, and that's a very dangerous thing. If the run command, control signal run command is released, the contactor remains shut, and that means that crane motion is still running. Well, incorporated with a contactor output on a radio receiver, we can monitor the position of the contactor itself, and if it's not open when it should be, the radio control will drop out. Nowadays, with the advance in electronics, we also can provide feedback from the receiver box back down to the transmitter. And one of the big uses of this would be to indicate weight restrictions on the crane itself, so we can prevent overload conditions. This can be then displayed on a screen indicating load weight or just the fact that we're in an unsafe load application. Another thing that's very simple but gets forgotten about is, especially with the small handheld transmitters, they have the potential to be placed, laid down, and forgotten about. And this can happen, let's say, for example, radio crane operator is loading a load of steel bar onto a flatbed truck, and they go up and they help to cinch down the straps, and they inadvertently lay the transmitter down on the flatbed of the truck leaves. Well, now there's no transmitter to talk to the crane anymore. It's gone. So with a tethering system, this problem can be eliminated. And another big application for radio controls is if you have, I'll call it an explosive environment. We have transmitters that one can use in these types of locations where the transmitter is, for lack of a better term, intrinsically safe. Now, the receiver box is not in these environments or in these atmospheres. That's located someplace else. But the transmitter will be designed such that you can use it in these environments. And I have some of the ratings listed here. This eliminates, like in a pendant station application, all of the electronic barriers that can be costly and cumbersome for wiring and troubleshooting that you would have to incorporate in these types of environments. Again, it's just the radio transmit that we're talking about. So in conclusion, radio remote controls, I'm going to tell you that basically they allow increased safety for the crane operator because, number one, they're not tethered to the crane itself, and number two, they get a very good visual on where the load is with respect to obstacles or personnel in the area. And with that, I think we're ready to move on to the next subject.
Perfect.
And that would be braking systems. Okay, so basically you're going to have, in most every crane application out there is going to be some kind of a braking system on the particular crane motions. You'll have them on the bridge motion, also we'll call it the traverse motions, bridge, trolley, swing motions, and most importantly, there's going to be some kind of a braking system on the hoist itself. That is important because we want to make sure that we stop and suspend the load while it's in the air and being moved. So I've got a number of different examples to describe here for you. Basically, whether in almost every braking system on an overhead crane, these are spring set, and they require some kind of force to overcome the spring set to release the brake itself. So in other words, they're fail-safe. The only application where you would not see this would be in a bridge crane where you'll have like a foot pedal in the bridge crane that's activated perhaps hydraulically, where it's like in a car or a truck, you push it down to stop. And then without the brake pedal being activated, you would continue to travel. But All of the brake systems out there, with the exception of the foot pedal bridge crane, are spring set and must be manually or forced open either through a hydraulic means or electronic means, whether the electrical energy is DC or AC or a thruster brake type configuration. All right, on a crane, the brakes. It is critical at a startup when the crane is built, designed, or new components are added that the brake be installed properly. More importantly, as we start further than that, the brake is sized properly based on the specification for the crane, making sure we have the proper brake for the proper application. Then it must be installed properly and then inspected properly once the crane is put into service. It is going to be, again, important based on the crane duty cycle and the specifications as to how the brake is going to be sized. A lot of times they're sized for an emergency stop application, where under full speed, full load, we're going to be able to stop predictably at a set distance. Okay? If it's a parking brake, it has to be sized such just to be able to hold the particular crane with full load without any movement. And again, this can be tied into a collision avoidance system that I talked about previously, where it'll be set by the collision avoidance system if the collision avoidance system detects that there's some kind of an obstacle in the path. I got some examples here of brakes that I hope none of you ever see. This particular slide shows a brake that been severely neglected. Up at the top, you can't really see it, but there's the brake torque spring, and it is corroded. That's the thing that provides the braking torque. If that fails, you have no brake. The brake drum itself in this application is fully corroded, both on the internal and external surfaces. With the corrosion again, you don't have any braking torque. If you look off to the side, the shoe holders for the brake, they're corroded. They could break or disintegrate almost at any time. Look at the base of the brake. It's deformed and it's corroded. The reason it's deformed is because the brake was not even mounted properly. There's 3 mounting holes on that brake, and only 2 were used. And if you look at the base on it, it is distorted. This application is setting itself for a very catastrophic event. Next slide, outdoor crane. This is quite common on drum brake applications and outdoor cranes. They're exposed to the weather. So there can be expected on the brake drum itself or the braking surfaces some corrosion. That oxidation or corrosion actually serves as, for lack of a better term, a lubricant that will minimize the braking torque until it's polished off. This is something that needs some maintenance, or perhaps a cover or something of that nature to prevent this from happening. The brake mechanism itself, all of the lever arms and the base and so on, are intact and in very good condition. Here's another example of a poorly maintained brake. If you look up at the top, I show you the brake torque spring, and you can see the corrosion on that. That's very sad. I wouldn't trust the crane with this type of a braking system. The brake drum itself and the hardware to fasten the drum to the drive shaft on the crane is corroded. The shoes are bad. The base has got corrosion on it. Again, this leads to a catastrophic event if it's ignored. Here's an example. This is quite common on shoe brakes here. The brake drum itself here is blued and scored, and that's because the brake shoes are basically worn out. When you have a situation like this, the braking torque is dramatically reduced. How is this rectified? Well, I take the brake drum off and either resurface it or just replace it, as well as replace the shoes. Again, this is due to lack of inspection. Some hoists will have what's called a mechanical load brake in the gearbox. It's a paw and ratchet mechanism that in the down direction, the mechanical paw locks into the teeth on the wheel, and it takes a certain amount of braking force to pop this loose. Well, these things are located in the gearbox on the hoist, and these can be difficult to inspect. And if you don't know what you're doing, it's best to have a qualified individual take a look at this. Depending upon the duty cycle and number of lifts and lowers per hour and the rating of each, or the capacity of each lift, these things can fail and can be a problem. So you want to make sure these are inspected. There's other types of brakes as well. Motor-mounted disc brakes. These are in some kind of a, I'll call it a container or a housing. And again, they're activated electronically, which forces against the spring and releases the pressure on the discs. These also require disassembly, and it's important, again, if one is not comfortable doing this, get a qualified individual to actually do the inspection. Because if these start to wear, one more time, the braking torque level is decreased and can potentially get to the point where there is no torque. And especially in the case of a hoist motion, this is a critical component that you want to make sure you inspect. So in conclusion, braking systems you're going to find on basically every crane motion, and it is important that these are properly installed from the get-go, sized properly for the crane, and then they are inspected periodically and maintained as per the brake manufacturer's recommendations. If you're not going to maintain a brake, you want to look at replacing it. That's my little slide. Take it to the dump and get a new one. Safety is most important. And that wraps up my portion of the basic presentation.
No, excellent. Thank you so much, John. We do have a couple questions that have come in. This one is has got multi-parts, so I'll just read it to you. Does the age of the crane prevent some cranes to have the radio installed? And at the same point, does the age impact adding a collision avoidance system?
The short answer to that is no. Whether it's a single speed, single motion contactor control, all the way on up to a sophisticated control, any one of these systems, whether it's a radio control or the distance detection collision avoidance system, can be adapted into the control scheme. Now, typically you'll find 120 volt control voltages, but you might have 24 volt, whatever. These are all available and can be very easily adapted into the existing control scheme of any overhead crane.
Okay, fantastic. Thank you. If a company has a great amount of radio computer signals going on, do you recommend a spectrometer used to determine radio signal usage?
Yes, in fact, that's something that's very important. This is where we're going to get into the application and the other RF signals in the area. And that's where we have this wide range of, we'll call it first, unlicensed frequencies that we can work in. And we'll have, if that isn't suitable, then we'll have to look at a licensed system. Now, the way the radios typically work are time multiple sequencing, so we'll send out not just a single signal, but it's a digital signal that has error correction bits that are used to adapt to interference, I'll call it, or sometimes people will call it the radio signal gets stepped on by a more powerful signal, that type of thing. So yes, that is critical that we know what we're dealing with. And again, if a licensed signal is a requirement for the application, we'll work with that as well. That's not an issue that really, other than knowing what we're dealing with, is something too complex to overcome.
Okay, thank you. Excellent. Next question. What safety controls exist to minimize unsafe load swings? Well,
there's a number of things. One of them, and it depends on what's driving the crane. If you use, an example, one of our impulse AC drives or omnipulse DC drive, we have an acceleration rate and a deceleration rate that are built into the drive itself. Okay. In addition to that, again, a little more sophisticated, if you're running a 3-motion crane and you're using one of our VG Plus drives, we can incorporate what we call our swing control system, where it controls, regardless of what the crane operator does, it controls XL and decel times and minimizes load swing. I'll just say on a side note that we have that out on our website. You can access how that actually works and actually visually see it. Other than that, yeah, if it's a contactor control, that's where you may look at going with a soft start if you have an issue with this, an SCR control, or replacing a contactor control with an adjustable frequency drive to help a standard acceleration and deceleration time, which then are set to minimize load swing.
Okay, perfect. Next question. How often should the brakes be inspected?
Well, that's a good question. That's a very good question. This will depend on the application for the crane, as well as if there's a required maintenance schedule for the crane itself. Bottom line is, one needs to have the brakes inspected to be sure that they're in full operation uh, braking capabilities. Now, that will be dictated by the crane duty cycle as well as where the crane is located. If you have a light duty crane that's used once every couple hours or maybe even just once a day, that brake is not going to experience much wear. Whereas if you have a high duty cycle crane, like a coil handling crane in a steel mill, you're going to need to have that brake inspected. It could be 3 months, 6 months, yearly. It depends on how the brake is being used as well. If you're using contactor control, the brake is then used to perform all the stopping functions on the crane. If you're using an adjustable frequency drive or one of our DC drives, the drive does a deceleration and the brake is not set until all motion is stopped. So those brakes and those applications will have less potential for wear than one on a contactor controlled crane. So, and then again, if your crane is outdoors, you have the potential for weather to affect the braking surfaces as well. Like I showed on that one slide with the corrosion on the brake drum. The rest of the brake was in perfect shape.
Yes.
So, I strongly recommend, if there are questions, talk to a competent individual associated with the crane and ask them for some guidance on that.
Okay, just on that topic, what are some signs or signals of brake issues that a daily and monthly inspection might not pick up?
Well, the first one and most critical is the hoist. If a run command is released on the hoist motion and there's a load on the hook and the load continues to drift down, that is a very good indicator that that brake needs to be changed, inspected, and fixed. I would take that particular hoist out of service immediately and have that issue addressed. Otherwise, there is a potential for a very serious event. Okay, that's most critical. Traverse motions as well. Again, if one's running the crane with a simple contactor control and the crane doesn't stop like it used to, it takes longer to stop because the brake is doing all the stopping, that indicates the braking surfaces are worn. Similar to like your car when you're driving down the road and you notice one day, gee, it's taking longer to stop. Hopefully you don't hit anything. You take it into a shop and have somebody do something to those brakes. Same idea on a traverse motion.
Okay. Okay, perfect. Another question. Do load sensors exist that stop operation if load exceeds performance standards of the hoist?
Short answer to that is yes. Now, again, with respect to our drives, we have what we call load check in the impulse drive products, where you will determine and set with a known load, and the drive then will sense in the hoist motion that that you're at that point or above it where you have said you do not want to lift the load. This will need to be set with test weights. Okay. Now, there are other devices, underhook devices that are out there that basically you take this underhook device, it's a strain gauge, and basically you put one end of it on the hoist hook and the other end on the rigging below, on the other end of the strain gauge itself. And the load cell then will give you an output, and then you have to do something with that output. Turn on a light bulb, incorporate it into the control logic on the hoist or what have you. So the short answer is yes, there are.
Okay, perfect. Okay, and one final question came in. I think this goes back to what we were talking about earlier, but how much drift is okay?
Now, are they talking about what motion they specify, if it's a traverse motion or hoist motion?
That's a good question. This question came from Al. This was talking
okay, well,
about
here, I'll give a short answer.
Traverse motion.
Traverse motion, it's going to be based on what the crane operator and the maintenance department and production says.
Okay.
That's the best way for me to explain it.
Okay.
Some people want an immediate stop. Some people want it to drift, I'll use to say 2 columns.
Yes.
It is important, however, in the hoist motion, there is no drift in the down direction.
Okay. Okay, excellent. Thank you. There might be another question coming in, but I just wanted to share something with all of you quick, a couple of things. If you can go ahead and advance to the next slide, John, I just want to cover some training that's coming up, as well as how they can reach you if they have any further questions. So the first thing is if you want to go back up. Let's give them your contact information should they have any questions. Perfect. So this is John's contact information. If you have any further questions, you can email him directly, or you can also respond back to the follow-up information I'll be sending out tomorrow with the link, and I can gladly pass it on to John, but this is how you can reach him. And then additionally, I'd like to just share with you a little bit of training. I know Magnatech does some training, and John could fill you in on that via email if you have any questions. I'm sure it might be also available on your on their website. But we just wanted to share some classes that we have coming up with you. We have, I don't know if any of you are have had a chain hoist repair certification in the past or overhead crane and hoist inspection. We just now have some online recertification classes we're offering at a fraction of the price and something you can do from your home just to get recertified. We also have a new CMCO qualified crane operator class starting in January of this year, or sorry, next year, January 10th through 11th. And then we have numerous other classes coming up on a variety of topics. You can find them all on our website, cmcodepot.com. This is our training website. And with that, John, if you can go to the last slide, please. I just want to share one more thing with you. We are very active on social media. Magnatech is as well. You can find both of us on Twitter, YouTube, where all of our safety webinars are there, as well as many other training videos. We're very active on Facebook, LinkedIn, Google+, Instagram, and then lastly, our blog. If you go to our website, you can find links to all of these social media channels. And again, Magnatech is a company we acquired recently, and they are now officially a part of Columbus McKinnon as of, I think, a year or two. And so we're really happy to be able to feature John today and his expertise as a trainer and an engineer. So again, if any of you have any further questions, you can feel free to respond back to the email that we'll send out or email John directly. And we just want to thank you all for your participation today. And yeah, it's Thursday. You have one more day left of the work week. So we wish you a great end of the week and weekend. And thank you again for your participation today.
Thank you.